So after the union, let's take a look at the intersection. Intersection is denoted by the set theory operation intersection or intersect, used as the reserved word in Oracle. The result of R intersect S is a relation that includes all tuples that are in both R and S, just like our intersection discussed in mathematics. Two operand relation of R and S must be type compatible and have the same amount of attribute. So that's going to be a very important thing. The other one is called the set difference, which is minus. So minus, what is minus do? This is actually pretty interesting. The result of R minus S is a relation that includes all tuples that are in R but not in S. The attribute name in the result will be the same as attribute in R, the first one. Whatever the results, it will follow the first table's attribute name. The two operand R and S must be type compatible. So once we understand that, let's directly look into an example can help you guys understand it easily. Saying that we have two tables, student table and instructor table. First of all, I want you to notice, usually we have one table with one attribute do the set theory operation with another table with one attribute. That's the most common thing that we do because that's very easy to control. However, like I said, it is also possible to do two columns and another two columns. So you have to have the same amount of attribute. More importantly, the attribute itself are type compatible. So first name Fn, even the name is different from Fname. They are obviously talking about the first name, so the domain are actually the same. And of course, when you try to define the tables, the domain must match each other. The last name is the same thing. So let's take a look at this. The first B table that we want to take a look is the result that when student is union with instructor. So you can see that everyone that appears in the table student or the table instructor or both will all appear. So we will end up with this B table over here. When we look into the C table, that means we try to intersect. So you can see that for the C table, student intersect with the instructor, we will end up with only the people that appear in both tables will survive the operation. So we only have two persons that are in both tables. If we use student minus instructor, which is this table, student table, and then take away anyone in this table that appeared in the student table, then we will only the one that survive, which means that we only have five students that survive because we know Susan is in instructor table, so we will take that away. Ramesh is in the instructor table, so we will take Ramesh away, and therefore we only have Johnny, Barbara, Amy, Jimmy, and Ernest that have passed the results. Here is a very important thing for you to see. If we use student union instructor, that is exactly equal to instructor union student. The result will be the same B table. If we use student intersect with instructor, it will equal to instructor intersect with student, which will result in C table. However, if we use student minus instructor, it will generate different results from instructor minus student. And that instructor minus student is actually the table over here because instructor, there are 5 peoples over here, and then you will take away that appeared in student table. So Susan will be taken away, and then Ramesh will be taken away. So you will end up with only 3 people in the operation. So this is like, it's very easy to understand. If you want to understand the D table, the English representation of this operation is that the students who are not instructor. So you will have these 5 students. For this table, if we use instructor minus student, that equals saying, please list out the instructors who are not student, and therefore the 2 students will be removed away and end up with this table. So D is very obvious that D table is not equal to E table. So intersection. To retrieve, let's take a look at another example. To retrieve the social security numbers of all employees who either work in department number 5 and directly supervise the employee who works in department number 5. So you know that based on this example that we see in our previous video, we find out the social security number of the employee who works for department number 5. You get 4 of those employees, and you try to intersect with the person that is direct supervised department number 5. So we will end up with only one social security number. So that if we try to run this code over here, you see that there is only one person who is working in that table. And if we try to see the minus example, we can try to retrieve the people who work in department number 5 and does not a supervisor who is not supervising employee who works in department number 5. So you can see that this is how we can use the minus operation and then be able to get the results. So we only end up with those 3 people who are not supervisors. And therefore, it has a lot of different applications that you can work on. Here are some common properties. This is what I've mentioned. R union S is equal to S union R. R intersect with S is equal to S intersect with R. And then they are able to have the associative properties so that no matter which one you do first, it will equal to the other part. However, this is very important to notice that R minus S is not equal to S minus R. So this is about the set theory operations. Before we conclude this one, I want to introduce you one more interesting things that you would be able to use, and then actually it's very helpful. And you actually already know this one, create table. So what is create table? You are thinking, why are you talking about the DDL part in here? Actually, create table as another important keyword over here is the as. What this can do is that you can create a table with whatever table name that you have after you append the as, and it will save whatever operations follows by these instructions. So many times the set theory operation give you only the crucial information, since the operation requires you to have the same number of attributes. So what they're trying to say is this one. I want to show you this. Saying that previously we only look for the social security number. So we know the social security number. However, if we change the question into retrieve the name of all employees who either work in department number 5 and does not directly supervise the employee who work in department number 5. So now, instead of social security number, I need the name. But we can only retrieve the name. Just like we see in the screen over here, we can only get their social security number. We are not able to get their name. So what should we do? We basically need to use social security number that we retrieve over here to join with the employee table so that we can get a name. Therefore, this is where we need to use create table as. So you can see that when we try to do the create table temp as operation, so all results, whatever results, you can do select from where over here. You can do whatever kind of operation, the queries. The result will be saved into the table name that you provide. So once you are able to do that, once you have the temp table, have the results, basically your temp table will equal to SSN with these 3 social security numbers over there, and then you will be able to use that to join back with the employee table to retrieve the name. So you can see that I'm going to select the first name and the last name from, of course, you can use equal join or you can use a natural join over here, because they definitely will have the same name of the attribute because the operation comes from the employee table itself. So you can see that if you learn the natural join as we discussed earlier, you will be able to retrieve the good results out of it and basically be able to find out who are those people to get satisfy the conditions over here. So the assignments I want to give you guys today is basically to retrieve So again, the name of all employees who have no dependent. So how would you be able to get the information out of it? Obviously, you need to retrieve the name, not just the social security number. So you basically need to find out all employee social security number and do something with the social security number you can retrieve from the dependent. So think about this. This is actually a very interesting question that you will be able to practice about the set theory operations. That would be all for the class today.